Hello, and welcome to Aggressive Physics. Today is day 143, and what we're going to do today is review modern physics. So I have a practice set that I hope you've solved already, and what I'm going to do now is take out the whiteboard and we're going to solve some practice problems dealing with modern physics. This is the most recent topic we've covered in the course, so hopefully it's fresh in your mind and you're able to solve those problems quite readily. So let's take out the whiteboard now and solve some modern physics sample problems. Thank you. All right, on to modern physics. Now question 1 says, what's the approximate binding energy of a helium nucleus that has a mass defect of 5.2 times 10 to the negative 29 kilograms? Well, in order to figure out the energy given a mass, we have to do equals mc squared. So it's 5.2 e negative 29 times the speed of light, which is 3e8 squared. And you have 4.68 times 10 to the negative 12 joules. So 4.7 times 10 to the negative 12 is choice 4. Number 2. A photon with a frequency of 5.48 times 10 to the 14 hertz is emitted in a mercury atom. What's the energy? Well, energy of a photon can be calculated by doing E equals hf. H is 6.63 times 10 to the negative 34. And F in this case was 5.48 times 10 to the 14 hertz. So 6.63 e negative 34 times 5.48 e 14. And the energy is 3.63 times 10 to the negative 19 joules. So 3.63 10 to the negative 19 is choice 4 again. All right, number 3. Number 3, sorry. There. Energy equivalent of 5 times 10 to the negative 3 kilograms. Once again, E equals mc squared. 5 times 10 to the negative 3 kilograms times the speed of light, which is 3e8 squared. So 5e negative 3 times 3e8 squared. 4.5 times 10 to the 14 joules. And that's choice 3. All right, on to 4. We have a data table, and we have energy of different photons. And then we have the graph, which shows E versus F. And it looks like that. Now, the energy and frequency are related with E equals hf. So if the equation is E equals hf, and we have slope, which is E over f, what that means is that the slope is going to be h. So it's going to represent Planck's constant. Now that means Planck's constant, which is number 1. 6.63 times 10 to the negative 34 joule seconds. All right, number 5. We're going to calculate the wavelength, which is going to be hc over lambda for a photon with 3.26 times 10 to the negative 19 joules. We have h, we have 3 times 10 to the 8, and we have lambda. Now h is 6.63 to the negative 34. So if we do 6.63 e negative 34 times 3e8, that'll take care of this side. The lambda's over here. And then we divide by the energy, which was divided by 3.26 e negative 19. We end up with a wavelength of 6.1 times 10 to the negative 7 meters. And that's going to be choice 1. All right, let's move on to 6. how much energy is required to move an electron in a mercury atom from ground state? So ground to H. What we need to do is look at our reference table for this one. And if we look at the reference table, we'll see mercury in the ground state is negative 10.38 electron volts, and in level H, it's negative 1.57 electron volts. And what you do is you find the difference between the two. 10.38 minus 1.57 is 8.81 electron volts. And let's see if the answers are in electron volts. And they are, and it's just choice 2. All right, let's look at 7. All right, we have a certain nucleus. We combine 2 neutrons and a proton. The mass of that nucleus is 9.106, 10 to the negative 3. Universal mass units less than the combined mass, so that's the mass defect. And we're going to find the energy released. E equals mc squared. Now, the problem is we're given the mass in universal mass units. So we're not given kilograms, so we can't use E equals mc squared directly. Instead, what we can do is we can convert using our conversion 1U equals 931 mega electron volts. And all the answers are in mega electron volts. So we're given 9.106 times 10 to the negative 3 U. And if we just say 1U is 931, we multiply and we figure out the number of mega electron volts. So 9.106 E negative 3 times 931, we have 8.5 mega electron volts. And if we look, that is choice 3. All right. For 8. We have a similar situation where we have a nucleus converted to energy. And the mass is 2 U's. What I'm going to do is just say 2, 1U, 931 mega electron volts. So 2 times 931 is 1862 mega electron volts. Now it looks like the closest is 1.9 times 10 to the 1, 2, 3. So that's going to work. And that's choice 4. All right, we're looking at number 9, and we have an alpha particle with plus 2 protons and 2 neutrons. And we want to know the total charge. Well, each proton is 1.6 times 10 to the negative 19 coulombs. So we double that, and we end up with 3.2 times 10 to the negative 19 coulombs. And that's going to be choice 4. All right, let's look at 10. Light of wavelength 5 times 10 to the negative 7 meters consists of photons having an energy of E equals hc over lambda. H and C are constants. Lambda is 5 times 10 to the negative 7 meters. So we're going to have to use 6.63 E negative 34 times 3 E8 divided by 5 E negative 7. And we're left with 3.98 times 10 to the negative 19 joules, which is choice 4. No, choice 3, because they round to 4. All right, 11. All right, we have a bunch of quarks. Which charged particle is more massive and opposite charge of a proton? So we have a proton, and it's got to be more mass, and it's got to be the opposite charge, so negative. So look at the chart. All right. The only one that has a negative charge that has a different mass is the omega particle, and that is -1 charge, and 1.672 is the mass compared to 0.938. So your answer is the omega particle, choice 4. All right, 12. Which type of photon is emitted when an electron in hydrogen drops from N2 to N = 1? All right, let's check our chart. We go to the reference table, and we go to the inside. We see that N = 2 is -3.4 electron volts, and 1 is -13.6 electron volts. So that's a 10.2 electron volt difference. And our choices are in the different types of particle range. So what we're going to have to do now is convert this to joules. So 10.2 electron volts, 1 eV, 1.6 times 10 to the -19 joules, and then do an HC over lambda to figure, or HF I'll do, 10.2 times 1.6 E -19. So that's my energy, which is 1.632 times 10 to the -18 joules equals HF divided by 6.63 E -34. And we have 2.5 times 10 to the 15, and we're finding frequency, so that's hertz. So if I look at my chart for the light section, and I look at 10 to the 15, that's going to be in the ultraviolet. So it's UV radiation, and that's going to be choice 1. All right. Well, we've done so many problems. All my black ink is run out. I'm down to the blue markers, so must be nearing the end of Agrosive Physics. Now this next one is 13, and it says a top quark has an approximate charge of. So we have a top quark, and I need to know what the charge of the top quark is. So I look at my chart. Top is plus 2/3 of an elementary particle, which is 1.6 times 10 to the -19 coulombs. So if I just multiply 1.6 E -19 times 2 divided by 3, I get 1.066 times 10 to the -19 coulombs. Now, since we have two options, we have the negative and the positive, we have to choose the positive, which is choice 3. All right, on to 14. Charge to mass ratio of an electron is, so charge to mass. Charge is 1.6 times 10 to the -19 coulombs. Mass is 9.11 times 10 to the -31 kilograms. They want us to just find the ratio. So 1.6 E -19 divided by 9.11 E -31. And the ratio is 1.75 times 10 to the 11 coulombs per kilogram. So 1.75 10 to the -11, 10 to the +11. So that's choice 3. Almost got tricked. All right, 15. An electron in mercury drops from energy level I down to the ground. So what are the different charges, or I'm sorry, energy values for I in the ground? So -1.56 and 10.38 negative. So what's the difference? 10.38 minus 1.56, we have 8.82 electron volts, which is going to be choice 2. All right, 16. We have a proton with a certain mass and a neutron. So a tritium nucleus consists of 1 proton, 1 plus, and 2 neutrals. And a total mass is 3.0170. What's the mass defect? Well, according to this chart, the proton is 1.0073 AMUs. And the neutron is 1.0087, but there's two of them. So it's 2.0174 atomic mass units. If I add those together, I'm going to get 3.0247, but the actual mass is 3.0170. So 3.0247, subtract that, and you get 0.0077 is the difference, which happens to be choice 2. All right, 17. What we have here is a chart with all different types of particles, and we want to find the classification. And it's either mesons, hadrons, antimatter, or leptons. Now, leptons are outside the nucleus, and a proton I know is in the nucleus, so I know leptons is out. Now, I remember seeing something about what makes up the different types of matter. And we have the hadrons and the leptons, so it can be a hadron. And are they all, they're all made up of 3 quarks, so they could be baryons, but that's not a choice. Now, we have leptons, definitely not, no. Mesons, definitely no, because it's not a quark anti-quark, because most of them are made up of 3 things, like the up, up, down, or the anti-up, anti-up, anti-down. So I'm going to say these are all types of hadrons. So choice 2, that's our best answer. 18. What's the representation between the energy and frequency of a photon? Well, what's the graph look like? The equation's E equals HF, and that's a linear relationship. So that's going to be choice 3. All right, 19. The charge of an anti-strange quark. Anti-strange. So according to our chart, strange is -1/3. So an anti-strange is going to be +1/3. And if we remember, 1.6 to the -19 is the charge of the elementary particle. So 1.6 e -19 divided by 3 gets us 5.3 times 10 to the -20 coulombs. And that happens to match with choice. Closest one is going to be choice positive. That's the problem. Choice 1. All right, 20. If the mass of one proton is converted to energy, it will yield a total energy of, well, E equals mc². Mass of a proton on the front of the reference table is 1.67 to the -27. So 1.67 e -27 times 3e8 squared. And let's see, 1.67 e -27 times 3e8 squared. And I get 1.503 times 10 to the -10 joules. Choice 2. All right, 21. Excited hydrogen atoms are in the n=3 state. So we're in the n=3. How many different photon energies can be emitted as these atoms return to the ground state? So if we're in 3, there's 2, and then there's 1. So what are our choices? We can jump from 3 all the way down to 1. We could jump from 3 to 2, and then we can jump from 2 to 1. So we have 1, 2, 3 options, which is choice 3. All right, 22. We have 2.29 times 10 to the -7 meter wavelength strikes an electron in the what atom? Mercury atom. So if we do the energy, that's going to be hc over lambda. So 6.63 e -34 times 3e8 divided by 2.29 e -7. Now the energy is 8.7 times 10 to the -19 joules, but we need it in electron volts, so I'm going to divide that by 1.6 times 10 to the negative 19 joules per electron volt. 1.6 e negative 19. And I get 5.42. So, we're in the ground state. We jump to a higher energy level. So which one can accommodate a difference of 5.42? What I'm going to do is just take 10.38 and subtract it from the B level, 5.74. And what do we get? 4.64. Well, let me go back to 10.38 minus the next one, 5.52. Nope, still too low. 10.38 minus 4.95. 5.43. That's got to be the one. Although it's not exact, that's the closest answer. 5.43, 5.42. So I'm looking at the D level. And that is choice 4. All right, 23. Total conversion of 1 kilogram into energy, which is going to be E equals mc squared. And we have kilograms, so I'm going to use the 1 times 3e8 squared. And it's 9 to the 16. 9 times 10 to the 16 joules. And that's E equals mc squared. Choice 4. All right, 24. We have force of gravity and force electrostatic. And we're comparing it to the distance, or r. Now, if I remember the equations, it's g mm over r squared, and it's k q q over r squared. So those are both indirect square relationships, and the only one that matches is choice 1. Those are the only indirect square relationships for both. All right, 25. What graph represents the relation between energy and mass when converted to energy? Well, energy, mass. E equals mc squared. Looks like number 2 shows the only squared relationship. Oh no. E and M are direct because C is a constant. Aha, trick. So that's going to show a direct relationship. That's going to be choice 1. And then 26. We're back to the chart. And we have a proton, which is 1.0073 U. Want to convert to energy, which is 931 mega electron volts, is 1 U. And 1.0073 times 931 equals 937.8 mega electron volts, which is closest to choice 1. All right, let's do 27. All right, we have 1 times 10 to the negative 3 kilograms. Want to convert to energy. E equals mc squared. So 1 e negative 3 times 3e8 squared, 9 to the 13 power. 9 times 10 to the 13 joules, which is choice 3. All right, now for 28. We have an E equals mc squared graph again, and it's asking what the slope is. Well, we just discussed that. If it's E equals mc squared, the slope is c squared, so the speed of light squared, which is 3. Now for 29, we have a chart, and we're looking at a frequency for D only, 2 times 10 to the 13 hertz. That's what type of light this is. Well, if we look at our electromagnetic spectrum at 10 to the 13, it's infrared. So all we have to do is look at the chart, line it up, and put the answer, which is 1. All right, 30. I have a mass of 1.53 times 10 to the negative 3 U's. We want to convert to energy. So it's 1U is 931 mega electron volts. And if I multiply 1.53 E negative 3 times 931, I get 1.424. And if I look, 1.42 mega electron volts is choice, well, it's mega electron volts, choice 2. And finally, for 31, we have an electron, and that's 9.11 times 10 to the negative 31 kilograms. And we're going to find the energy, equals mc squared. So 9.11 E negative 31 times 3E8 squared. And our final answer for review is 8.2 times 10 to the negative 14 joules. And that's choice 2. And if you've followed along with all these solutions and you've corrected all of your mistakes, you are adequately prepared to take your state assessments. And I wish you good luck.